Can you tell which remarkable property of the CDF is on display in this image? Let me give you a hint. In each plot, in the bottom right in blue is a PDF, and right above it in orange is the corresponding CDF. Let's see it in action. Let's sample a random variable x from the normal 2-2 PDF. And then let's form another random variable y by plugging x into its own CDF. Now here's the remarkable result. This random variable y will have the standard uniform distribution. Perfectly standard, perfectly uniform. As if we simply sampled it from the boring uniform 0-1 distribution. But we know that our standard uniform random variable y had quite a journey. It was born in the normal 2-2 distribution and then put through a mind-bending transformation via the CDF, and then by some sheer magic we ended up with a standard uniform distributed random variable. But the ever more remarkable fact is that this result holds no matter what distribution we pick for x. This is nothing short of incredible. The property of the CDF that we just looked at is called the probability integral transform. We'll come back to it at the end of this video, but here's a very brief intuitive explanation of why it works. In particular, let's look at why if a random variable x has the standard normal distribution, then the random variable y obtained by plugging x into its own CDF will have the standard uniform distribution. Picture two equal width x intervals, one near the center of the normal, call it yellow, and one out in the tail, call it purple. Now imagine that we sample millions of random variables from this standard normal distribution, and we are observing this sampling process as it unfolds. Because the PDF is much taller in the yellow region than in the purple region, we'll sample random variables in the yellow region much more often than in the purple region. Where the PDF is tall, the CDF is steep. Where the PDF is short, the CDF is flat. So, the random variables that originate in the purple region, and there are fewer of these, right? They get compressed into a much narrower span of y values than the more frequent random variables that originate in the yellow region, and are stretched into a much wider span of y values. This stretching of high-density regions and compression of low-density regions is what equalizes everything and produces a uniform 0-1 distribution.